Great. So I'm going to introduce our next speaker, who's Professor Ian Hutchinson. I'm going to just tell you a little bit about him and then hand over to him. He's Professor of Nuclear Science and Engineering at MIT in the States, and it's very good of him to come across and speak to us, as he has done before, I should say. His research is on fusion, and he's done a lot of work on that. I'm a geologist, so I roll off my tongue. I'm not bothered about 50 million years, or even more. His plasma has reached 50 million degrees, which I think is pretty amazing. And I can't actually imagine that. I can imagine 50 million years, but I can't imagine 50 million degrees. But there you go. Now, he's often given talks on science and Christianity. He's a well-known scientist, as I just said, and he's written a book or two. Perhaps we'll hear about some of his thoughts on that. But in the spirit of this morning, when we heard that Tim was a tennis table champion, I'll just tell you one of Ian's interests, amongst many others, is fly fishing. Now, I've just come back from 2 weeks in Scotland, and I can tell you there's an awful lot of flies. There's these little things called midges that eat you alive when it's a day like today. So that's why everybody goes to Scotland fly fishing, I guess, isn't it? Ian, let me hand over to you for your talk.
Thank you, Bobby. Well, thank you. It's a pleasure to be with you again at the Faraday Institute. And I appreciate the opportunity to share our thoughts about science and religious faith with people of like mind and like interest. I also enjoy the fact that you've set aside, half an hour after each talk for questions. And I generally find that the questions that I get are the most interesting time for me as a speaker, and maybe even for the audience. In fact, so much so that my latest book, which is coming out in September, is based on all the questions that I've been asked at various Veritas forums that I've given over the years. 223 of them, and they're all on the subject of science and faith. So the title of my talk is what does science learn from theology, and what does theology learn from science? In medieval times, there was very little distinction drawn between theology and natural philosophy, as science was then called. They were part of a much bigger enterprise of knowledge called philosophy. But this title that I've been given arises, I think, from a modern perception that arose through what is often called the scientific revolution, that science and theology are very different. And what I plan to do is to talk generally about the way that the relationship between science and religion developed, how they sometimes support and even encourage one another, how they inform one another, and how they sometimes constrain and correct one another. And I'm going to illustrate this later on in the talk with a few biographical vignettes concerning some famous scientists. Now, I'm a Christian, and so I understand my own faith and theology best, and so I shall be, by default, referring to Christian theology, although I think what I say will sometimes apply more broadly. I'm also a working scientist, a physicist, and not a philosopher or theologian. I find myself in the first day devoted to philosophy. But I will say a little bit about the history of ideas, and probably more about that than the content of science. But perhaps you'll have some more specific questions at the end that we can tackle afterwards. Let's see if this works. Yes, good. So, although science, the study of nature, and theology were once hardly separable, I think it's fair to say that most people today would regard them as being about as separate disciplines as you can get. And that separation came about very slowly over centuries, beginning in the medieval period, and it came about through the writings of philosophers who were actually theologians, but who were mostly not, in any sense that would be recognizable today, scientists. They generally didn't do experiments, they didn't make observations, and they spent most of their time in libraries reading and interpreting ancient books not in laboratories, of which there were actually none, so that's why they weren't in them. The writings of the ancient Greek philosopher Aristotle and commentaries on those writings were probably the most influential books that scholars read. Aristotle himself was a keen observer of nature. His theories were genuine attempts to explain the commonly observed features of the natural world, especially biology and geology. And his philosophy was felt by the medievals to be in reasonable harmony with Christian theology, and as a result it became endorsed and adopted by the church, the Roman church of those days. Aristotle taught that there are four elements: the earth, air, fire, and water. So I'm sure you've all heard of that idea. He also taught that there are four types of cause: material, which is what something is made of; formal, which means the form or structure of something; efficient, which is roughly what causes something to be or to happen; and final, which means something's aim or purpose. But these causes were intermingled. So, for example, for Aristotle, things have a natural place and a natural motion, so that there is an intrinsic downness to heavy elements like earth and water that causes them to move almost purposefully towards the center of the earth, and there's an intrinsic upness in light elements, fire and air, that causes them to move away from it. Now, the gradually growing separation of theology and natural science accelerated very strongly around about the beginning of the 17th century. It was accompanied and empowered by a move away from the reliance on ancient and authoritative teachings concerning nature and towards experimental investigation of nature. It was epitomized by a move of explanation, speaking in the Aristotelian categories that I just mentioned, away from explanation in terms of final causes and natural propensities towards efficient causes and especially observably mechanical causes, things pushing or pulling one another. And the growing emphasis was on practical and useful knowledge rather than speculative theory. So this separation of science and theology proved to be enormously fruitful in developing practical and persuasive knowledge about nature. And I think it was also helpful to religion and theology in ways that we will discuss perhaps later. But in any case, this transformation of thought and its result is what is often called the scientific revolution. Now, it can lead to, the enormous success of science can lead to, and does lead to, presumptions. I mean, one modern view is that the fantastic progress of science during the succeeding 4 centuries up to today shows that science is the right way to gain knowledge of anything, and that claims to knowledge based on religion or anything else other than the methods of science are spurious. And that view is, as we heard this morning, called scientism. It endorses a story that somehow long ago ignorance and superstition ruled human thought, but that now we know better, we know how to get true knowledge, and therefore science has triumphed over superstition and religion and theology and disqualifies them from any claims that they might have had now to describing reality. And that triumphalist view of scientific progress is very common, especially in academic circles, I might say. But as we heard this morning, it's incoherent because it ignores the vital importance of all sorts of knowledge on which science itself depends. An alternative is to move to the opposite extreme. Instead of supposing science and religion to be competing to describe the same realities, some people argue that science and religion do not compete because they have nothing whatsoever in common. This view says that science and religious faith address entirely different topics with which each is concerned. The Harvard paleontologist Stephen Jay Gould, who is an agnostic with respect to religion, but a scientist who nevertheless recognized the breadth of human knowledge and aspiration, he subscribed to this view by saying that science and religion are, quote, non-overlapping magisteria. They don't overlap at all. And this is now, these days, rendered by this acronym NOMA. If this NOMA, non-overlapping viewpoint, were true, well, then my lecture would have to end and I would have to depart, because it would be obvious that the answer to the question that I've been asked is there isn't any way in which they help each other. But that's not what I believe. And so the rest of my talk is going to try to explain a kind of middle ground which regards science and theology as different in important ways, but also possessing common interests and similarities, which mean that they have learnt and should learn from one another. Here is the actual quote from Francis Bacon concerning that's known by most widely concerning this metaphor of the two books, the book of God's words and the book of God's works. Let no man out of a weak conceit of sobriety or an ill-applied moderation think or maintain that a man can search too far or be too well studied in the book of God's word or in the book of God's works, divinity or philosophy. And that statement is a characteristic representation of a constructive and indeed a theological view of the relationship between religious and scientific knowledge that was promoted right at the beginning of the scientific revolution. It reaffirmed the view that had existed, since at least Old Testament times, that nature testifies to certain key attributes of God, that nature reflects God's glory and wisdom. So Psalm 19, for example, begins, "The heavens are telling the glory of God, and the firmament proclaims his handiwork," saying that nature speaks of the character of God. Or Psalm 97, verse 6, "The heavens proclaim his righteousness, and all peoples see his glory." Or Psalm 104, "How many are your works, O Lord? In wisdom you have made them all. The earth is full of your creatures. There is the sea, vast and spacious, teeming with creatures beyond number, living things, both large and small. There the ships go to and fro, and Leviathan, which you formed to frolic there." So Francis Bacon's declaration is that the study of the book of God's works, nature, is just as important as the study of the book of his words, the Bible. And it's thereby asserting a distinction between science and revelation. It's recognizing that distinction, but it's also implying that they both speak of God. So it's affirming that while theology and science are separate and worthy in their own spheres, they both help us to understand God, and they indeed help us to understand each other. And so I think the two books metaphor is equally helpful today as it was then. Well, I'm guessing that you all have a pretty good feeling for what we mean by science, but I think it's worth taking just a few moments to clarify it, and in part that's because the meaning of the word science has changed greatly over the centuries. Long ago, the word was used to refer to any systematic study of a particular discipline or set of ideas. And Renee this morning implied that usage is still commonplace on the continent, but although I actually don't think it's so commonplace as he was implying. So I don't think it's a continental distinction. I think it's a historical distinction more than that, but we could talk about that later. At any rate, today, what we mean in the English language when we use the unqualified word science is generally natural science, what once would have been called natural philosophy. It was physics, chemistry, biology, geology, and cosmology, and so on. And that's the way I'm using it, and that's the way I'm interpreting the word here. So forgive me if there are folks who are active in, for example, political science, or if you think about another term like domestic science. Those are not science in the modern sense, in the sense that I'm using it now. They are science in the archaic sense, in which they can be systematic studies of any particular discipline. So I'm trying to avoid the ambiguity that can otherwise arise here. Science, natural science, is the study of nature. It depends on two principal characteristics which gather together the many features that I'm sure you're familiar with of science. And the headings under which I put them are these: reproducibility and clarity. So science describes the world insofar as it is reproducible. If an experiment or an observation, it gives a certain result here and now when done by me, let's say, then when done by someone else, somewhere else, at some other time, the result has to be reproducible. If they get the same result, that's a reproducible result. And in order for us to know that we're getting reproducible results, science depends upon the ability to express the results of experiments or observations sufficiently clearly and unambiguously that we can tell whether reproducibility has been obtained. So science, for example, uses measurement and mathematics and a host of other practices in order to ensure that clarity, and avoid ambiguity. But we know there are many things in the world that don't possess those reproducibility and clarity, and yet are important objects of knowledge. And thus, in the sense that I'm using the word, they are not science, and yet they can involve knowledge. So science is necessarily limited. We've heard this morning. It doesn't encompass all of knowledge. And I would give, as an example of a discipline that is not scientific, but that everyone would declare possesses knowledge, an example of history, or perhaps sociology, or literature, or language, or politics, and so on. So scientism is a terrible mistake. I also wanted just to mention that the idea of nature is, of course, also important in understanding natural science. But it actually isn't a terribly good way of defining what science is, because in practice, what nature means in this context, at least today, is the normal course of events. And that's because reproducibility is essential to science, and so therefore, in effect, science studies what is the normal course of events. So today, I think it's true to say that nature is defined by more or less defined by what science studies, at least in this context, rather than science being defined as the study of nature. Well, now, one of the most striking aspects of science is that science is remarkably successful in eventually producing agreement among different observers. And that is, frankly, in rather stark contrast with the situation in theology, where disputes often seem interminable. Science seems really to be able to resolve disputes to the point where an overwhelming consensus of scientific opinion is formed, whereas in theology, such consensus is elusive. I don't mean to say it's instant in science. It's not instant. It sometimes takes centuries to develop those consensus, but it does seem as if we get there. Now, this observation might lead one to suppose that even if there exists such a thing as theological knowledge, yet scientific knowledge is somehow better than theological knowledge. and therefore it's more useful and so much better agreed upon, that perhaps theology hardly counts as knowledge. It's certainly the case that the explanations of science are enormously persuasive to me, and that's one of the reasons why I'm a scientist. I think science is discovering true facts about the world, and I find that exciting and valuable. And I think there is a true sense in which science produces better consensus and produces more definite and practical knowledge and application than does theology. But I want immediately to go on to say that the same is true of a comparison between science and, let's say, politics, or literature, or sociology, or ethics. And so I reject the view that science's success rules out the relevance of non-scientific knowledge. I instead insist that science has chosen, actually, to answer certain specific questions, and in fact that those questions are, by and large, the easy questions. Those questions that can be analyzed through reproducible experiment and described with unambiguous clarity. But the hard questions of life, are just as important, even though their answers are more difficult to discover. Okay, well now I want to move on to give two examples each of science learning from theology and theology learning from science. And the first two examples are going to be ways in which science and theology support one another, okay? And the latter two are going to be ways in which science and theology constrain one another. And I only have a time to give a very brief outline of these, but there's plenty of time for questions later. So, first principle, or first example. Natural science derived its principles and its birth, in part, from theology. It's a complete misunderstanding of the history of ideas to think that the principles of science were always contrary to theology, or that the main thing that enabled science to flourish was overthrowing the influence of theology. Maybe there is a sense, I think there is, in which science has outgrown theology, but in fact, science grew out of theology. You can think, for example, about the idea of the laws of nature. These are so familiar to us today that anyone with even the most passing acquaintance of science understands what we mean by the laws of nature. So it's very hard to realize how unfamiliar the concept once was. It can be traced back to the beginnings in classical and biblical sources, when the law that was meant was most like human society's laws. It was the pronouncement of a lawgiver, and it was understood that way by authors such as Augustine and up through the Middle Ages. And it began to be a vital part of natural philosophy, and to take on more mathematical character through the work of theologians like Robert Grosseteste, and who was Bishop of Lincoln and Chancellor of Oxford University. Sorry about that, being in Cambridge. Or Roger Bacon, who was another Oxfordian. What can you do? Or Bradwardine, who became Archbishop of Canterbury. And all of these traced the laws of nature to being laws of God. I've given you a few references that you can pursue this further, these kinds of things further if you like. The idea of practical and experimental investigation received a major boost from the same Francis Bacon that I quoted earlier, Lord Chancellor of England. He was actually no scientist himself, but he's famous for having advocated rigorous induction. And he, in The Advancement of Learning, criticizes philosophy that is, quote, not a rich storehouse for the glory of the Creator and the relief of man's estate. In other words, and this comes, by the way, to another of our themes for this week, human flourishing, Bacon was arguing that science, the science that he was advocating, should be for the relief of man's estate. It should be for the good of people, for human flourishing. And doing that depends upon experiments, not just doing armchair philosophizing. And science found its birth in a fertile matrix, cultural matrix of biblical theism. There are numerous encouragements to the works of experimental science that arose and arise from biblical theological understanding of the relationship of the creation to the Creator. I don't have time to develop this, but it has been written about extensively by a number of authors for many decades. And so it's a remarkable fact that science was still born outside of the society where biblical theism provided a fertile environment in which it took root. So that's my first example. So now what about an example of science helping to support theology? Well, I've already given several Old Testament passages demonstrating the idea that nature testifies to God. A New Testament passage that puts the same point is when St. Paul says, what can be known about God is plain to them, because God has shown it to them. Ever since the creation of the world, his invisible nature, namely his eternal power and deity, has been clearly perceived in the things that have been made. This is a quotation from the first chapter of Romans. I actually find it particularly significant that the characteristics of God that Paul cites are the impersonal characteristics, his invisible nature, his eternal power and deity. I think those are more obvious in nature than his personal characteristics. And I think that's true today. I think many scientists of history have been devoted Christian believers. That's perfectly clear from the records. But in addition, there are many today who do not subscribe to any organized religion, and yet they speak in theological language about nature. So, for example, Albert Einstein emphasized that he did not believe in a personal God, but he often made reference to God in talking about nature and the transcendent and the inexplicable in it. Examination of the natural world and the transcendent aspects of it provide abundant evidence of nature possessing enormous size, power, stability, consistency, comprehensibility, and so on which our very existence depends. And features like these have traditionally been interpreted as a reflection of the character of God. Like many other secular scientists, Einstein, in the end, adopted a kind of pantheism, effectively taking the universe itself to be a kind of God. Now, perhaps that adoption can be interpreted to be metaphorical, but I think actually in Einstein's case and in many others, it's actually a bit more than a mere metaphor. Okay, moving on. What about religious beliefs about nature being constrained by science? Well, this observation hardly needs any development. Christians and the church have too often opposed scientific developments. The most celebrated case, which is Galileo's run-in with the Roman Catholic Church over the Copernican cosmology, is actually not a very good example of the church's scientific views being held back by theological conservatism, because when you dig deeper, you find it was a fascinating and complicated situation in which, for example, Galileo's belief that the Earth orbits the sun was correct, but the reasons he offered for it were not decisive, and some of them were scientifically incorrect. The science was debatable, and he had been encouraged by the Pope, the VIII, to pursue his studies, but then he went behind the Pope's back and published his arguments, his dialogue, in a way that avoided it being vetted by the church. So the Roman Church was in the midst of a big struggle with Protestantism at the time over who controlled interpretation of the Scriptures. And Galileo had been told to keep out of Bible interpretation, but he didn't. So there are many things behind that, more than the usual hackneyed view of the church opposing science. But still, the church was incorrect in respect of interpreting statements in the Bible about the stability of the earth as implying that it doesn't move. And eventually, the church did learn from science. And indeed, I would make the case that the Bible doesn't contain science, and we should not go to the Bible for science in the sense that we mean it today. The flip side of that is that natural science is rightly constrained by religious principles. One discipline can constrain another most appropriately in the area of the constrainer's expertise. So science's expertise is in the behavior of the natural world, so it constrains theology in discussions of the natural world. But by the same principle, theology constrains science in the areas of theology's expertise. And one of those areas of expertise is in morality and ethics. So the ethical and moral acceptability of scientific practices is strongly dictated by religious beliefs and commitments. So in the US, which is where I live, every research institution that receives financial support from the US government is required by federal law to have an institutional review board that evaluates the uses of human subjects in research. And at a minimum, that board must ensure that the risks are minimized, that consent is obtained, that data is monitored and privacy observed, and that possibly vulnerable subjects are protected. So there's therefore already in our system in the US, I'm sure that the same is true in the UK and other European countries, there's already a system and an acknowledgement that scientific practice must be constrained and subject to ethical restrictions. Now, I'm sure you can think of many examples of ways in which that's appropriate, and I'm going to skip developing one of them. But for example, embryonic stem cells was a hot button issue, starting 10 years ago. An example of ethics constraining science. But one of the potentially misleading aspects of the title that I've been given is that it expresses the the question in terms of two abstract concepts. What does science learn from theology, and what does theology learn from science? But science and theology are not organisms that learn. Humans learn. So it would perhaps have been better to ask, what do scientists learn and what do theologians learn from each other? At any rate, what I want to do for this closing section of the talk is to address more directly some of the individual personal aspects of how science and theology together influence the beliefs, attitudes, and actions of scientists and theologians, and explore a little bit how certain individuals have integrated their scientific and religious beliefs. Now, a major fraction of the scientists up to the 19th century at least were clergy, that is, ministers or monks, etc. And that's not terribly surprising because scholarship as such was initially practiced largely by the religious orders and in universities that were religious institutions. So intellectual life as a whole and the church were for very many centuries deeply intertwined. But I want to talk about some lay scientist Christians, people like whom you can think of, maybe Pascal, Boyle, or a couple that you might have thought of, who are notable for their religious theological writings as well as their science. And the first one I want to talk about is James Clerk Maxwell. He has been called the greatest theoretical physicist between Isaac Newton and Albert Einstein. And he, together with Ludwig Boltzmann, invented the mathematical techniques that enable us to put on a sound footing the kinetic theory of gases, the way that molecular gases work. But most notably, he established the theory of electromagnetism in the form of what's called Maxwell's equation, which unified light, electricity, and magnetism. So here's Boltzmann's distribution. An MIT professor can't have a talk with no equations, okay? So here's the Maxwell-Boltzmann distribution, and here's one of Maxwell's equations. Maxwell's equations predicted radio waves, and they're still essentially how all electronics is described today. So, by the way, that's an answer to one of the questions that was asked this morning. Actually, science is usually extremely important in influencing our lives, electronics being one of them. Okay, so Maxwell actually spent 3 years studying philosophy as well as physics at the University of Edinburgh before going to study mathematics as an undergraduate here in Cambridge. And he was initially in Peterhouse, but then he moved to Trinity later. While at Cambridge, he expressed his attitude to the relationship between his Christian faith and intellect generally, not just science, in a letter to his school friend in which he said he intended that there should be no holy ground to be willfully left unexamined, but instead that he was going to plow up all of his Christian commitments and never hide anything. In other words, he was dead against blind faith. He wanted to think this through. And there's very considerable evidence from his writings, both as a student and in later life, that Maxwell did really probe deeply into the foundations of his Christian beliefs and found them to be intellectually satisfying. And there's also evidence that his scientific research was guided by philosophical approaches. For example, William Whewell was the master of Trinity in those days. Whewell was a philosopher and a lot of other things, and though his ideas owed as much, I think, to theology as to nature. Well, Maxwell's knowledge of the Bible and respect for it was very deep. In his earliest biography, there are extracts of letters to his fiancée, Catherine, in which he expounds passages from the New Testament in the form of almost miniature sermons. And he also remarks on a Sunday school class that he taught while he was visiting a clergyman friend. And when he was appointed to the chair of natural philosophy at King's College London, in the inaugural lecture that was expected of every new professor, he included not just scientific but also philosophical and theological reflection. For example, he introduced an idea which he was later published in the magazine Nature that is as follows. Quote, "We're therefore unable to ascribe either the existence of the molecules or the identity of their properties to the operation of any causes which we call natural." He's referring to the fact that hydrogen has the same spectra when observed from stars very far away as it does on Earth. And then he says, on the other hand, the exact equality of each molecule to all the others gives it, as Sir John Herschel has well said, the essential character of a manufactured article. Thus, we are led along a strictly scientific path very near to the place where science must stop. In later years, Maxwell became a very public figure. He became the first Cavendish professor of physics, experimental physics at Cambridge. And he was written a letter by the Bishop of Gloucester and Bristol about his ideas relating his faith and science. And the bishop was wondering whether the creation of the sun after the creation of light in Genesis 1 could be harmonized by regarding the creation of light as referring to the ether, which in those days was supposed to be what carried electromagnetic oscillations. And Maxwell replies to this rather naive question with great politeness and, I think, great wisdom. If it were necessary to provide an interpretation of the text in accordance with the science of 1876, which may not agree with that of 1896, it would be very tempting to say that the light of the first day means the all-embracing ether. But I cannot suppose that this was the very idea meant to be conveyed by the original author to those for whom he was writing. I should be very sorry if an interpretation founded on the most conjectural scientific hypothesis were to get fastened to the text in Genesis. The rate of change of scientific hypothesis is naturally much more rapid than that of biblical interpretation. So that if an interpretation is founded on such an hypothesis, It may help to keep the hypothesis above ground long after it ought to be buried and forgotten. The irony here is that that hypothesis of the ether was abandoned about 20 years later. So Maxwell resisted a naive concordism with a penetrating remark that history has shown to be highly appropriate. For Maxwell, science and theology, though remaining separate enterprises, provided to each other important signposts within their different spheres. Well, my second person was born 40 years before James Clerk Maxwell, and he is perhaps the patron saint of our current meeting and institute. He was a Victorian scientist whose background is a complete contrast with Maxwell's, and I won't go into it too much. But he left school at age 13 and was apprenticed to a bookbinder. And of course, that's where he got most of his education. He read books voraciously. But he was sorely in need of systematic guidance about how to put his ideas in order. And he found this in a book that was entitled The Improvement of the Mind, of which the first part is devoted to the development of what might today be called critical thinking, how to observe and how to read and critique ideas in books, and how to conduct conversations or disputes, and lots of other practical helps to learning. Now, you might say, well, what's this got to do with theology? Well, the author of that book was Isaac Watts, and those of you who are Christians know that he was a famous nonconformist minister in London in the 18th century, and is known even today as the author of many wonderful hymns that we still sing in the Christian church. For example, When I Survey the Wondrous Cross on which the King of Glory died, etc. So he was the author of that book. And Faraday himself was actually a lifelong adherent of the Sandemanian Church, a nonconformist Christian movement that sought to return to principles of church organization and practice that directly reflected those of the New Testament. He was tremendously prolific. He has more than 5 scientific phenomena or laws named after him. It depends how you count them. And that's very fitting because he expressed his preoccupation with laws, saying, for example, God has been pleased to work in his material creation by laws, and the Creator governs his material works by definite laws resulting from the forces of nature. This is in part the designer's art. And these were presuppositions as much as they were conclusions, probably more than they were conclusions for Faraday. And so the point is that Faraday said that his theology strongly influenced the style and direction of his scientific investigations. I'm going to skip, in the interest of time, I'm going to skip a final remark about brotherhood, because I want to say just a few words about Arthur Stanley Eddington, who was probably the world's leading astrophysicist of the first quarter of the 20th century. He was the discoverer of galaxies, and he worked out the inner structure of stars, and he's the person actually who verified Einstein's theory of general relativity by observing the gravitational bending of light during an eclipse. He was also a lifelong Quaker, and even as an adult spent weeks at summer camp with his fellow Quakers, and later in life he wrote several books of popular science and of religious philosophy. And the Quaker distinctive that perhaps helps us most to understand Eddington is the Quaker teaching concerning the inner light that they believe enlightens every human. And that teaching is reflected in an emphasis on silent, direct encounter with the divine in the believer's soul, which characterizes Quaker worship. Eddington repeatedly relied upon his scientific intuition in a way that I believe reflects a habit of inner conviction based on spiritual practice and commitment. So, and that's evident even in his philosophical writing. He makes it clear that he regarded those direct, intuitive insights and perceptions as having equal validity. It's not the case that he, as Bertrand Russell claimed, that he tried to deduce religion from the fact that atoms do not obey the laws of mathematics. That's a misrepresentation of Eddington, because he strongly opposed all attempts to deduce religious belief from any scientific results. But he did feel that quantum uncertainty implied an openness of the world that removes certain difficulties that are inherent in determinism. And in part, it's because of his extensive philosophical writings that we can see in Eddington's thought, the implications of science for theology and theology for science, in forming attitudes, bringing successes, and perhaps also in imposing limitations. So let me close and summarize. An essential element of the change in ideas represented by the scientific revolution was to separate science and theology and regard the facts of science as being discovered by experiment and observation, rather than by intellectual speculation from authoritative sources, even theological sources. Nevertheless, it's a mistake to imagine that science is a totally independent enterprise, uninformed by other approaches to knowledge, including theological ideas. Science sprang from a fertile cultural environment formed by biblical notions of creation. It pursues laws analogous to those of a divine lawgiver, and scientists throughout history have been inspired and influenced by their religious beliefs in their practice of scientific research and even in the directions and theoretical development of it. Science is not all the knowledge there is, and we need to beware of extrapolating science's success into scientism. From the other side, theology has always been inspired and guided by observations of the natural world. The Holy Scriptures obviously reflect background cosmologies that, from a scientific viewpoint, are superseded by modern science. That fact ought to guide us to some degree in our interpretation of the Scriptures, especially to avoid projecting back into the Scriptures a kind of modern scientific viewpoint. But I find that regarding the Bible as the inspired Word of God can be reconciled with natural science as we know it today, provided we avoid that same scientific attitude which is so widespread, but so contrary to the thinking of many great scientists, Christian scientists of history. Let me leave it there. Thank you very much.
Thank you, Ian. Well, that does leave plenty of time for questions or comments arising from this talk or others. Let's start at the front here.
If you could just say a bit more about the separation. Do you see it as happening in the medieval period and done, dusted, or a whole long period from medieval period onwards?
It clearly took a long time getting going. The separation per se really was an abandonment of Aristotle. I mean, in a certain sense, medieval science, insofar as it depended on Aristotle and endorsed Aristotle, had a theological element to it built in from that point of view. But what we again often refer to as the scientific revolution, which, you know, what the dates of that were is debatable, but obviously Copernicus, you know, is the middle of the 16th century, and by the time we reach Newton, we could consider the revolution to be in full force. At least 100 years is when that separation largely took place. If you think about the Royal Society, founded in 1660, if memory serves, its motto was nullius in verba, which means, roughly speaking, on nobody's word. So it was inherent in what the Royal Society set out to do was to depend not upon written sources, not upon however hallowed and old they were, upon, in a certain sense, the sources that we look to theologically, but to rely upon observation and experiment. So approximately 100 years, 150 years, but you can see the seeds growing from well before that.
Thanks. I can add that the charter for the Royal Society, given by Charles II, was that they should do their studies for the glory of God and the advancement of mankind, meaning humankind, of course.
Thank you.
So they saw science as being a way of helping humankind,
Absolutely.
which indeed
so
it has done in many, many ways.
Separating theology from science didn't mean banishing theology.
Yeah.
Not at all. It was, as Bob said.
Yeah.
Thank you for making that point.
So I have a comment. So all the natural sciences, even that a chunk of the research doesn't deal with religion. For example, you find, some questions are like, what is the effect of this component on this? So both of them are not entirely related to any of the, the existence of God or something. So even the chunk of the natural sciences, I would say the work can go on without, commenting on the religion. But evolutionary biology is something that it looks like it's contradicting with the religion and evolutionary biology. So, and secondly, I think that as a Christian scientist, even more Christians can come into research, and even in the the fundamental biology as well as other natural sciences, they can do with a full commitment, and with such programs like what we have, like we can warm up and orient the students like me.
Yeah,
Yeah.
thank you.
Yeah.
Thank you for that comment. I don't know whether you all heard that, but I think that's an important comment. I did say in the middle of my talk that there is a sense in which we might regard science as having outgrown theology. There is a sense in which science now operates very independent, seemingly very independent of theology. I think that's true, and I wouldn't argue with it. But I made the point that science grew out of theology. I also think that's very clear if you look at the historical record. I don't want to make that point too strongly, though, because I think science still depends on certain types of virtues, which we would often think of as being Christian virtues or religious virtues. I'm thinking of things like truth-telling. Which is tremendously important in science. As Tim pointed out before, you have to be able to trust your colleagues are telling you the truth when they're describing their experiments or when they're publishing their research. And we found, to our chagrin in the last few decades, that's not always the case, that there is fraud and as well as mistake, but there's very often scientific fraud these days, and we're rather nervous about it in the sciences. That is a way of seeing that science depends upon, still remains dependent upon certain personal characteristics, which are part of, if you like, much more dependent upon our religious and moral commitments than they are upon our intellect. But thank you for that very interesting comment.
I have a question around science, theology, and culture. When culture, sorry, I don't know if
Culture,
I'm clear.
culture, yeah.
If I'm clear enough. Now, when the Bible, I'll start with Bible before Quran or so. When the Bible is being written, I don't know the influence of culture about that. The same thing with Quran in Medina or Mecca and other holy books we have. So what is the role of culture in the subject of science and theology or faith? For instance, I'll give you an instance of Africa, for instance. Though we have most Africans to be either Christians or Muslim. But at the same time, we still have like some percentage being African traditionalists. These are a set of people that believe, probably my grandfather, they believe in a set of God. They don't really have Holy Scripture where they can make reference to, but they believe that there's God somewhere, either monotheistic or pantheistic. They believe God is somewhere. They believe that it can wrought works and all that. I'm just thinking, could culture have a role in this subject? And at the same time, I don't know if anybody have actually thought of this. If science developed, for instance, in an environment such as Africa, where, let's say, there's no Christian, there's no Muslim, it's just African traditional religion, what are we going to be talking about right now at this present moment?
Okay, thank you. Yeah, culture is obviously very important, and I made very brief allusion to what I regard as being one of the crucial supporting aspects by which the biblical worldview helped science to be born and to grow. If I were to develop that a little bit more, I'd make remarks like that the Bible teaches that the creation is separate from God, and so therefore that enables people to investigate experimentally the creation without fear of violating the divine. The Bible teaches that the creation is, in a certain sense, a choice of God, a free choice of God. That is an encouragement to the work of experimental science. We can't just figure out what the world is like by just sitting in our armchairs and thinking God's thoughts after him. It's better, because God had choices, for us to go out and find out what those choices were. And one can develop these ideas further. So I think that there were deeply biblical ways in which natural science gained the impetus that led to its birth and subsequent growth. Of course, there were many other influences too, and these are to do with civilization, the presence of civilization, as it once would have been called. In other words, some minimal level of technological development, political stability, certain degree of simply practical wherewithal to do the things that one needed to do. Writing, maybe printing even was important in the scientific revolution. So there are many other cultural things which influence things. Without wishing to belittle African culture at all, if you don't have a culture which has writing, it's very hard to imagine how science could get going. So I think your hypothetical is a little bit, today, obviously, there are plenty of people who in Africa, probably everyone, basically knows how to read and write. But if you think about the Africa of 100 years ago, it would be unthinkable to me that science could get going in that environment. So yes, culture has been tremendously important for science. And the main points that I was trying to get at before is to say that the importance of religious aspects of culture is also significant, and this gives the lie to the idea that somehow science and religion have always been at war, and that in order for science to flourish, you must get rid of religion or push superstition to one side. I think that's not quite true. We do need to get past certain untrue beliefs about the natural world. Eventually, that's what science leads us to do. But actually, in the early days of science, there was a tremendous mixture of superstition and real science. So if you think about Tycho Brahe, who was responsible for making the detailed observations of the heavens on which Kepler relied in developing Kepler's laws of motion. Tycho was perhaps the first really serious measuremental astronomer after, Ptolemy or something. And yet he was also not just an astronomer, he was an astrologer. So he cast the astrological horoscope, of the future Christian IV of Denmark. And so there was this strange mixture of science and what today we would call superstition in those days, and it was a gradual process of their disentanglement. Sorry, that was a long answer to a very interesting question. Yeah.
Yeah, I think you're right that publication was a really fundamental point in founding of science as a body of work, and that's why I think the founding of the Royal Society is often taken as the first proper science, because they also founded the philosophical journals, which are still running, actually the longest running journals in the world, and that was really important in that development. René had a question, I think.
Thank you very much, Ian. So you said science can learn from theology, and what they learned from theology was that science incorporated the notion of law. That's one of the...
That's an example.
That's one example. Now, what were the examples of the other way around? So there you reverted to the language of constraining. So here's it's an exploratory question. So if Christian theology is to learn from science, what sort of thing could it be? So would it be, well, given that there is chance or randomness at the quantum level, does that teach us anything about God's character, or does it teach us anything about divine providence, the way it operates, that we learn things about, or many biologists teach us or learn, say things about how groups behave and how morally, how moral convictions are being formed? Does that say us something about, well, the theological interpretation or accounts of sin, or I think I had another case. So is there anything from science that we can learn in the formulation of, well, the central part of Christian doctrine, sin, the character of God, etc.?
Very good question. Very good question. I start with certain easy answers to the question. So if we have things that are well-established scientific facts, the age of the universe, of the earth, and so on and so forth, those place upon us certain constraints about how we can make sense of, let's say, the Bible, of our scriptures. Okay? So I think that's a very simple way in which science helps us, helps theology, and constrains theology. I think we have to be rather careful about it, because it's very easy for secularists to stray beyond what is established science into essentially a kind of scientific philosophy. And the question of evolution was mentioned earlier, and I sort of sidestepped it a bit, and I don't. So anything I say about evolution, you can discount, because I'm a physicist, not a biologist, so I can say what I like about it, because I'm not an expert. But I mean, I think, for example, evolution has implications in theology, and if, as I do, you accept that common descent and natural selection are mechanisms that we can see have been at work over history, that has certain implications for theology. I don't think they're disastrous implications, neither did many of the first readers of Darwin think that they have disastrous implications, but other people thought they had disastrous implications. But the problems arise if you elevate that constraining process into one which becomes essentially an autonomous way of philosophizing, of developing a worldview. And so when Christians today think about evolution, very often what they're reacting to is not the scientific theories that I just mentioned, but the conversion of those theories into an overarching philosophy which discounts and claims to have disproved the theological traditions of Christianity and of most other religions, for that matter. And I think that your question is important to me, not only because here's an example, but also there are examples of ways in which we must approach these with a certain degree of caution, not necessarily buy into all the claims that science has shown that, because many of those science has shown that claims are claims about things that science has not at all shown, okay? But they're somebody's deductions from that. So that's kind of my response to your interesting question. Thank you.
Gosh, there are so many questions I want to ask. Well, the bar might be my refuge this evening.
I'll be there.
Good. One of the tensions, potentially, is that within the realm of theology stroke Christian faith is exactly that, faith. And I'm reminded of the words that faith is being confident, what we hope for, but assurance of what we do not see. So if there is a problem there in terms of what science and theology have to learn from one another, maybe in the words of yes, minister, or yes, prime minister, from where I get a lot of my theology, I have to say. It's that sometimes we can lay, particularly with regards to this relationship, it seems to me, upon the English language, a burden that it's too great to bear. In other words, that sometimes we're looking for answers that actually neither the religious texts nor actually science can necessarily help us with. Now, that's not to render what we've done so far this afternoon useless, but I just wonder at what point in avoiding scientism do we have to just render ourselves neutral before some of the dichotomies or tensions?
I don't know how to answer that question. You raised the word faith, and I thought we were going in a certain direction, and then your question went in a different direction. Let me say a couple of words about faith, because I think faith and science are often contrasted, and faith and knowledge are often contrasted in ways which I think are unhelpful. I didn't have time to develop it, but I actually think that there is a meaningful sense in which we exercise faith in science. And Tim alluded to this, or developed it a little bit this morning, and pointed out that we have to have trust in one another's pronouncements, in one another's publications, and so on and so forth. And that even scientists learn most of their science not, by observation and experiment, but by words. So nullius in verba cannot be followed through in everyday life, and it cannot actually be followed through in science. And so I do think there's a meaningful sense in which the dichotomy between faith and science, or between faith and knowledge, faith and reason, is far overemphasized in our culture. Nevertheless, and I think Tim made this point very well and clearly, there is a point at which we have to say we don't know everything, yet we have to move forward in a certain sense in faith. And that is certainly something that our religious traditions, a Christian tradition, calls us to, not to necessarily knowledge of everything, but a willingness to trust and move forward consistent with what we take to be our core beliefs. And maybe that was what you were gesturing towards in citing Hebrews. Of course, Hebrews says faith is the assurance of things not seen. It doesn't say faith is opposite to knowledge. It says faith is, in a certain sense, what gives us what sight doesn't give us, okay? So not what reason doesn't give us, not what knowledge doesn't give us, but what sight doesn't give us.